Hello, welcome. May I ask you to introduce yourself and your role, and also tell us a bit about your projects and what does it mean to be part of the European Maritime Days and this amazing opportunity for knowledge sharing, but also cooperation and networking.
Well, thank you. So my name is Rémi Gruet. I'm the CEO of Ocean Energy Europe. We are the European and international organization representing ocean energies, which are at the moment mostly wave energy and tidal energy. So our objective is to help our members develop these technologies. So we deal a lot with the European Commission, with the Parliament, the member states, to put in place projects for ocean energy. The reason we come to EMD is very simple. It's a great opportunity to meet everybody around the oceans. So there are people we often have on the phone, and we can speak to them directly here. So it's good networking opportunity. In fact, this morning I had a quick chat with Commissioner Sinkevicius, which you can't really do that easily in Brussels, despite the fact he's 500 meters from our offices. And he promised me that he would put in a good word with his colleague, Commissioner Gabriel, on research for funding for ocean energy. So again, that's something you can't do every day. So yeah, that's why we come here. We also had a workshop about the blue economy sectors that provide solutions for decarbonization. So very centered on offshore renewables, a bit of biotech as well. And yeah, trying to showcase to people what's happening in the field at the moment. Yeah.
Are you hopeful for the future? And what is, in your opinion, the role of renewable energies, but also new technologies like the one that you are promoting in shaping a more sustainable future for our ocean?
So yes, I'm very hopeful. Thank you for that question. I think it's very clear now that wind and solar PV, photovoltaics, are going to be the backbone of the electricity system in Europe. And when I say backbone, I mean probably around 70% of our electricity consumption being covered by these two technologies. Now, they're both variable. Generally, I mean, one turbine can stop, but a system never stops. So there will always be some production, but it varies a lot, right? So it's good to have other technologies like wave energy, tidal energy, who, for example, produce at different times. So this way, when there is less wind, there is more tidal. Also, we've noted that wave energy tends to produce after the wind has stopped. So the waves we use are generated by the wind. So when the wind starts, the wind turbines start spinning. And then a few hours later, the wave devices start spinning as well. And then when the wind stops, the wave devices continue spinning for a number of hours. So I'm very hopeful that these technologies will enable a higher penetration of cheap renewable technologies on the grid, without having blackout issues or without having the need for resorting to gas, because that's not really something we want, especially at the moment. It's not really a good solution for the climate or, in fact, for peace. So, yeah, very hopeful.
Thank you so much. And what is, in your opinion, the impact that this type of technology have on the marine environment in the way you are, or because you are in a initial stage, and I'm sure that there is this thought about enhancing maybe the marine environment and ecosystem instead of minimizing the impact. Can you tell us a little bit more about this aspect?
Yeah, it's a question we get often. So two aspects. First, on tidal, we put tidal devices where there is a lot of current. And if you've been in the sea, you know that when there is a lot of current, there is nothing on the ground because everything gets swept away. No sand, no biomass, nothing. It's just rock. So when there is just rock, there is no biodiversity to destroy. And on top of it, what we do is just putting machines on the ground. So it's you only have contact in a number of points. It's a very small impact, if you like. And we've noticed that the fish, they don't like the current either, because they need to eat to produce the energy to swim. And the more current, the more the energy is spent. So in fact, we've seen them use our machines as protection from the current. So they don't come in the front and slam into them like some people might think. We don't produce sushi on an industrial scale. but they hide behind them. So that's for tidal. For wave, it's a bit different because you can put wave devices a bit everywhere. So we need to be more careful about, for example, marine mammals, dolphins, porpoise, whales. We're too close to the shore for whales to be really much of a concern. But yeah, dolphins, for example, they're super smart. If you've had the chance of swimming with them, and I have, in the middle of the sea, you can see that they can avoid pretty much everything. But nevertheless, we want to be sure. We don't want to just think. So we have monitoring devices on every machine. We have cameras. We have Doppler effects, audio, so sensors, and we try to monitor everything that happens around it. So whether it's fish, whether it's mammals, to see a bit how the environment interacts. And again, to go back to the positive impacts you were mentioning, we've seen with the offshore wind sector that it's possible to create more biomass by having hard substrate. So a big turbine, it's metal or it's concrete, and this creates a hard shell for shells to attach to, for algae to attach to it. And then you create a mini ecosystem around this turbine, which is going to stay there for 20, 25 years. So it's a worthwhile ecosystem to have, brings in more fish. Sometimes it's an exclusion zone for fisheries as well, which allows the fish stocks to replenish, because despite what some of our stakeholders here might think, the fish stock is not unlimited. So yeah, there are also very positive impacts that go beyond just not damaging the environment, but actually improving it.
Very interesting. One last question, time-wise, when do you think that this technology can be part of our portfolio of a solution? And how much funding is needed to get there?
Lots of funding. No, not so much funding. Well, I'll get to that in a minute. When? When basically depends on how much, because tidal has a number of pilot farms in the water already. The only thing we need is financial support, because the technology is roughly at the same price as floating offshore wind at the moment. It's roughly, fine, it's not even roughly, it's like exactly around 250 euros per megawatt hour, just like floating offshore wind. So that can happen the minute we get funding on the table from the member states, from the Commission. There are different solutions for that. Wave is a bit more early stage, so probably needs another 5-6 years to get to that level. But essentially, yeah, tidal could go ahead very quickly and very rapidly. It doesn't take time to build the machines, it takes time to build a project, so the permits and everything. And as for how much, we've estimated that with 1 billion euro, we could reach a pre-commercial level of support right now. We are also requiring feed-in tariffs or revenue support schemes, whatever they are. They can be different things. But essentially, because the euro per megawatt hour is a bit higher than the market at the moment, we need a top-up for projects to be financially viable and to be able to go to the bank and say, hey, can you give me a loan? So yeah, that's there is a bit of support, but essentially tidal is already there today. And by 2030, we hope it's going to have about 1 gigawatt installed in European waters. And I can't tell you exactly how much in terms of consumption that would be.
That was my next question.
The figure we have for 2050, which is a total potential with current technologies for Europe, is about 10% of EU consumption. So we're never going to be wind, we're never going to produce 50% of electricity in the EU, but we can be the 10% that help balancing the grid, like I was saying earlier. And exactly bridge the gap to 100. Voilà. So that's our positioning. Thank you very much.
Thank you. Thank you very much.